So we talked about temperature programming in the last video, and we said that the oven can fluctuate its temperature throughout the analysis. And this allows you to separate your compounds a little bit better in the gas chromatography system. All right, so now we are kind of to our last piece of the instrument itself. And this very last piece is something that we call the detector. And the detector is what I'll refer to as the eyeballs of the instrument. So this sees stuff that comes off of the column, and it doesn't really know what it is, but it tells you that it has picked it up at least. So it's telling you the positive presence of something coming off of the machine. Now, it's up to you to figure out what that is. And there's a couple of ways that we do that, and we'll talk about that later. But the detector sees the stuff, and it reports back to you that it has picked up the positive presence of something coming off. All right, so let's say that this is the column, the end of the column. And on the inside of the column, I've got some sample that's getting ready to come off in one big clump, right? So it's zooming through the column, it's going down my 100-meter column that's coiled up, and out it goes. The next piece that it will venture into is something called the detector. And there's different types of detectors. So there's various forms of this, and there's various ways that the detector does its job. However, what happens is that a component will come through and it will go into the detector box. And the detector says, uh-oh, I see something, and it needs to report the positive presence of that in some form or some fashion. So this is really kind of what happens in a layman's term if you just want a very simplistic view of what goes on. In the beginning, no sample is coming through at all, right? So this detector flushes itself out. And it's like hitting the tare button on the analytical balance. You make it read 0. So on the chromatogram, we see a flat line. Nothing is really going on at this point in time because no sample has made its way into the detector chamber. All right, well, the way that a detector works is that when a component comes inside of the chamber, and when it does what it does to pick up the positive presence of something that has came in, then the detector gives you a signal and it skyrockets up. And then this component will make its way through and out of the detector. And when it comes out of the detector, it doesn't see it anymore and it comes back down. All right? So that's kind of what you want to see when it concerns the world of chromatography. You want to see these very sharp, narrow peaks, meaning that this sample is coming into the detector as a big cluster and out it goes at one time. All right? Now, the problem is that sometimes this doesn't really happen. So here's another option that could go on inside of the detector. You get a column. That column incorporates some sample into the detector, but the sample's not really clustered together. The sample kind of comes in a little bit by little bit. Well, the detector will still pick up that presence. It will still say, hey, I'm seeing stuff. Stuff is coming in my way. I'm recording it in my chamber, and I need to tell you that something has came in. So in that version, the detector will take a look and it will flatline in the beginning, and then it sees this stuff trickle in. It's not coming in as one plug or one thing at one time, right? These are various molecules of one component. That's what this is. So if this is maybe THC, because we talked about that in a previous video about picking out the column. If this was THC, there's going to be tons of THC molecules that are coming through the column. Ideally, all of those THC molecules will be grouped together. They'll hang out with each other, and they'll come into the detector together as a group, and they will leave as a group. But if I've not picked out the right column, or if I've not picked out the right temperature or the right setting, then maybe that component will not stay together. It will trickle into the detector. And what you'll see is that because it trickles, it tells you that there's a positive readout. But the problem is that it takes its time to go up, and maybe that component takes its time to come back down because it's so spread out. And then it will flatline when no more samples coming through. Okay, so that's kind of the representation of what happens in that case. And that's a no-no, right? I don't want this type of chromatogram. It doesn't mean my detector's bad. What it means is that my separation is bad. There's temperature settings that need to be adjusted. There's flow rates that need to be adjusted. There's a column that needs to be changed. Something's going on because my detector is telling me, listen, in this scenario, stuff is coming in and it trickles in. It doesn't come in and out very quick, which is ideally what you want to happen. Okay, so again, this is what we call the chromatogram, and the chromatogram will begin to tell me the story of how these things separate from each other. So the very first detector that we need to talk about is called a TCD. And TCD stands for something very specific. Well, the D, you would probably realize, stands for detector. The T stands for thermal. And the C stands for conductivity. So TCD is the most common detector that is on a GC unit. If I do not tell a company what kind of GC system that I want, detector-wise, they will always assume you're talking about a TCD detector. It is the most common because it is universal. It can really see pretty much everything that comes its way inside of that chamber. The problem with TCD is because it's universal, it's not sensitive. Now, when we say this, our concentrations typically part per million on the GC system. It can give you part per million measurements. However, it can't go any lower. And for some of the environmental people and pharmaceutical people, they need to go lower than that. They need to go to part per billion range instead. All right, but TCD is a good place to start. It's a very good universal detector. It's a very good instrument, pretty reasonable at this point in time that we can acquire and put into a laboratory. But this is kind of how a TCD works. And again, I'm oversimplifying it, but it's okay. It gives you a general understanding of what goes on. So thermal conductivity. There's a wire. Imagine a wire between these two posts, right? And this wire is heated up. Thermal, right? And we get just helium gas coming through. Well, helium gas is going to flow over this heated wire, and it begins to cool that wire down. So what happens is that the TCD detector stabilizes itself in the very beginning. Only mobile phase is happening. And you get an idea of how hot this wire could get. All right, well, when I inject a sample, this sample is going to come into the TCD detector. And this sample goes over and flows over this heated wire. Well, there's extra stuff now. And that extra stuff is going to make this wire cooler. And because of that, the temperature drops on the TCD detector. Well, after that sample leaves, that stuff now that's not flowing across that wire, and that wire begins to heat back up. Well, when it heats back up, it goes back to the baseline and it comes flat again. Okay, if another component comes through, it does the same exact thing. It goes down and then it comes back up. The problem is that with us in the world of chromatography, we like to view peaks this way, up. We don't like to look at peaks this way, which is down. So what the software will do is that it will come through and it will say, okay, well, we're going to take this signal. We know it's cooling down the wire, but that means the positive presence of something. And then it comes back down and it goes back down to baseline. So this is what we see. The positive peaks that point upward. However, you got to keep in mind this is thermal conductivity, and we're playing off of heated wires and filaments that's on the inside of the detector. And actually, the thing happens backward. But for us, due to convenience, we take this type of signal and we flip it so that way those peaks point upward. All right, so that's a thermal conductivity detector. That is the most common type of detector that's out there. That's the way that it does its job. It's very universal. It plays off of heat, and when stuff flows across it, it will pick that heat exchange up and it reports to you in terms of a signal that we call a chromatogram. Now, there's plenty of other detectors that are out there that we can choose from. And in the next video, I'll mention a couple of others, but we won't go into detail about them. But I'll at least give you some abbreviations that you might find, and I will at least tell you what they would be used for and why they would be chosen in the first place. But other than that, we won't go any further into detail.